Okay, now we're looking at a problem where we have delta H formation values given, and we need to do Hess's law to find out the energy change. So the first thing, we look at the equation that's written down. Is it balanced? It looks balanced. That's the first step. Make sure it's balanced. And the next step is we need to write down the constituent elements from where the substances are formed. So if we look at all these, we have three things in common. We have carbon, we have plus hydrogen plus oxygen. Now let's balance these. We have two carbons, so we put that there. Hydrogen is a diatomic molecule. We have 6 of them, so it'd be a 3. 7 oxygens, so it's a 3.5. Remember, it's diatomic again. Now, first thing, we know it's delta H formation because we've got that F for formation there for values. Okay, so instead of combustion where all the arrows are pointing downwards, initially we start off by pointing all the arrows upwards. Let's do that straight away. Okay, now what we need to do now is look at a route. Okay, so a route to the products. Before we do that, let's put the values in. So we have a minus 185 for the methoxymethane. Oxygen, I'll come back to in a second. Carbon dioxide, we have 2 multiplied by minus 394. And for the H2O, we have 3 moles multiplied by minus 286. So the oxygen here, because it's already formed, it's already in the standard state, the value is going to be 0 because we don't require any energy. So we can easily just remove that because it's not relevant for us. So, okay, now we have 3 values. We need to find a route. Okay, we need to find a route to the products. How are we going to do that? Let's change a different color. So if I go downwards and there, that looks like a viable route for me. So I actually need the eraser first. I'm going to remove this arrow and then add my new arrow, which is going to be in blue. So we're going this way, and then we can follow the route to the products. That makes more sense. So one step, we have to change the actual sign. So it was negative, so it becomes positive. Now if we do the maths, positive 185 plus we have 2 multiplied by minus 394 plus 3 multiplied by minus 286. And I'm going to pause here and let you guys calculate and see what value you get here. And also bear in mind that it's burning in oxygen, so you know it's going to be a combustion reaction. So the delta H should be negative anyway. So I'll get my calculator out and let you guys calculate this as well. So let's have a look at this. So we have minus 394. Well, let's clear this up first. We have minus 394 multiplied by 2, which equals minus 788 plus, let's open brackets, minus 286 multiplied by 3 and close the bracket, equals, then we need to add the positive 185, and this equals, you get a value which equals minus 1461, minus 1461, and the units will be kilojoules per mole. As you can see, it's negative, so it's exothermic. Now just to recap, because there are formation values, all the arrows pointed upwards towards the products. Okay, then we look for a suitable route to the products, so we have to switch one of the arrows, and then if we look at the delta H formation values, they will have to also be reversed. So if it's negative, it becomes positive, and vice versa. And compute the values into your calculator, and there you go. I hope that makes sense, guys.